Okay, hi, I'm Rich Moran and I'm a development practice lead at HAMBS, which provides software and services to the private health insurance industry around Australia. HAMBS is currently undergoing a massive multi-year digital transformation program, which has given us the opportunity to do things with technology, pardon me, to do with things with technology at the ground level. So Stephen has had the opportunity to do some really interesting stuff with SpecFlow. That started out as a passion project, and it has become rolled out across the development process within HAMBS. Now, to those who've seen the promo video for tonight's talk, I'm sorry, it's awful. However, it was really quite representative of what we were doing and the conversations and questions we were asking. These questions included how we reduce the amount of manual testing for new features, how we can reliably increase the coverage of automated regression tests, and can we directly use the acceptance criteria from our user stories to write our feature files for our testing. So, as we found out more about the testing framework that Stephen had created, we thought we'd give it a try within the existing product space. And I want to call that up because that framework was written for a largely greenfields project, and we wanted to see if we could actually make it work in more of a brownfields area. So to get things started, we set up a 2-day workshop, which included business analysts, developers, testers, pretty much the entire team. We looked at new features, we looked at bugs of various sizes and complexities, and we developed some solutions for testing those things. This workshop was invaluable because we came out of it, because it highlighted the strengths and weaknesses of HAMBS' use of SpecFlow. And at the end of this workshop, we decided that we would be continuing with SpecFlow, but we would have to scale back our grand plans for what we could do with it. So 2 of the decisions that came out of that exercise were that within the existing product space, we would limit our use of SpecFlow to our bug fixing activities. So we wouldn't try and implement it on new features. The other thing that we decided was that we would not be able to get business analysts to write the feature files for us. So that was an interesting little outcome. But before I go any further, before I give you any more spoilers, I'm going to hand over to Stephen. So Stephen's going to talk about SpecFlow as it's been implemented at HAMBS. He's going to share insights and lessons learned, and also the trade-offs that were made during the implementation and our development. So the story of SpecFlow at HAMBS is really Stephen's to tell, and I think you're going to find this to be a really interesting story. So over to you, Stephen.
Okay, thanks Rich for the introduction. So I'm Stephen. Tonight I'll be talking all about SpecFlow. I guess I'm going to break it into 2 parts. So the first part I'm going to talk about, I guess, what is SpecFlow for people who haven't used it before. Show some of the features of SpecFlow, what we can do with it, essentially. And then I'm going to talk about specifically how we customize that specifically for API testing at HAMBS. So we did quite a lot of customization and tailoring to make it work as well as we could. So I'll get into it and start with what is SpecFlow. So it's basically a behavior-driven development testing framework written for .NET. So I'm sure pretty much everyone is familiar here with the given-when-then type syntax. It's very common in user stories or acceptance criteria, sometimes called the Gherkin syntax. So basically SpecFlow is writing tests in that kind of syntax. Here's a quick example. Given a customer has added an order, when they provide payment details, then a confirmation email is sent to their email address. So the way that works in SpecFlow, and there are similar tools, by the way, for other languages like Cucumber, something people might have heard of. So we create our test scenarios in that sort of English type language, given-when-then, and then those steps directly translate into our .NET code. So we have methods that kind of bind directly to all of those steps, so we can kind of implement whatever we need to for those steps. And it's good to know that we can execute these in SpecFlow. We can execute it. We can basically choose whatever, well, not whatever, but from 3 of the most common test frameworks, XUnit, NUnit, or MS Test. So we can use one of those to run the test behind the scenes. It kind of doesn't matter too much what we choose. It's sort of that part of it is largely abstracted away when we use SpecFlow anyway. So I would suggest if you've already got like a test framework that you're using for other stuff, then it's probably just use the same one, providing it's one of these 3 at least. Okay, so why would we use SpecFlow? Well, there are a few, I guess, reasons that we might choose that. So firstly, the test scenarios are quite easy to read. So you have that sort of given-when-then syntax. It's very much a English type language, something most people can understand. You don't have to have a good technical knowledge to get the gist of it. So that's the first reason. Another benefit is a lot of the test steps can be reused. So often we have steps that are common between different tests. So because they just bind to methods, they're not like one class implements a whole test. We can kind of mix and match and use those steps between different tests, and we just get to reuse the same logic. And also, at least in the traditional way of using SpecFlow with that high level kind of language, we kind of get this bridge or link between different roles in the company. So obviously developers who are doing the code, but then testers and BAs who are often writing this in a higher kind of level language, particularly in user stories. So you can get that situation where you start from a user story where a BA might have written some acceptance criteria, and then it can kind of translate all the way down into the actual tests which are implemented. Okay, so brief history of SpecFlow. I'll tell you why I've bothered to give this in a second. So SpecFlow was started in 2009. 2019, it was acquired by Tricentis. So they've produced some other test products as well. And it still does exist, and it's still a thing in Tricentis, but this year really, it was forked to a new project in GitHub called Wreck and Roll. Now the reason it was forked it was actually done by the original developer of SpecFlow, Gaspar Nagy, is because Tricentis haven't really been supporting SpecFlow over the last, I don't know how long it is, last year or so. They haven't really updated it for the latest .NET versions and things like that. So there was a bit of concern in the community, people who are already using SpecFlow. So Gaspar kind of stepped in and he decided to fork it. Most of SpecFlow was already open source anyway, so that was fine. So he created Wreck and Roll. It's essentially the same thing. At HAMBS, we moved over to Wreck and Roll from SpecFlow just because now we've got the latest updates, the latest .NET. Well, maybe not .NET 9 yet. So I'll be using the terms interchangeably. I'll probably refer to SpecFlow more, but just know that it's essentially the same thing. All right, so I'm just going to give an example of how this binding works in SpecFlow. So on the left here, we have a scenario. I've used Uno because I like Uno. So the scenario is a draw 4 card is played. We've got a few steps. So given a game of Uno with 4 players and the yellow 9 is drawn from the deck, when the first player plays a draw 4 card, then the next player needs to pick up 4 cards. So on the right, we can see we've got some steps written in code. We've got some methods for each step, and then we've got some attributes at the top. So we just have to give the appropriate attribute to each method, and then we give a bit of text. So that text obviously translates straight from our step text. So we can see how we can map that up. So we'll be looking at that in more detail, pretty much right now. So I've just got a little demo I'm going to show. And first I'll just point out a couple of things, just general SpecFlow things, or Wreck and Roll in this case. So we do need to install a plugin. I'm using Rider for my IDE, but very similar for Visual Studio, so there's an extension for that. So that basically gives us formatting for our features. So all of our features, which contain scenarios, they live in files with a feature extension. And so it gives us nice formatting. It also gives us some IntelliSense. So basically it already kind of knows what steps are available. And if I start typing, I don't have a lot of steps available, but you can start typing, you already get the steps that are available, which is very handy. It gives you kind of immediate binding. So if I press F12 on, oh no, I've got my function keys all set up wrong. Sorry, it decides to change it on me when I'm doing a demo. Yeah, so if I press F12 on one of those, it goes straight to the method in code, which is kind of nice. The other thing is when we build our project, we automatically get this file generated. So we can have a quick look in here. I've set it up to work with XUnit, so we can kind of just, if anyone's familiar with XUnit, we can see we've got a fact, or in this case, a skippable fact for our test method. It's already added a couple of traits based on what the feature name and description is. And it kind of just goes through and runs each of our steps. But we don't really need to care too much about how it's doing it. It's just good to kind of know, I guess, behind the scenes how it's working. So what I'm going to do is I'll go to the code. I'll just put a few breakpoints just to quickly show how this works when we run it. Can't remember in Visual Studio if it's the same, but at least in, I imagine it is, at least in Writer, we can just kind of run it straight from the feature file. So that's just going to debug through. All right. So you can see it's come to the first step, which is that given one. In this case, we're just creating a new game instance. I'm just saving it as a local field in this class. I'll just continue. So now it's coming to the next step. So the next step is a yellow 9 is drawn from the deck. So here we're using our existing instance of the game, and we're just calling this draw initial card and using creating a yellow 9 card. Then we get to the when step. So this is like the actual thing we're testing. So the first player plays a draw 4 card. So here we are creating a draw 4 card. We play the card, then we get some consequences. So the consequences are basically what happens in the game after this card is played. And we're just going to store those to a local field. And then finally we get to our then step. So we're basically just saying, or asserting. We're using fluent assertions, by the way, so we get some nice syntax. So we're just asserting that these play consequences contains the consequence that we expect, which is that the next player needs to pick up 4 cards. All right, so that passed, which is good. All right, so I'll just go back and I'm going to give a bit more detail on the feature files just so you can see the different things that we can add to our feature files. So first up, every feature needs a name. Obviously, Demo2 wouldn't be a great name in reality, but often we just map that to a user story. It kind of depends how we want to organize things. So then we can have one or more scenarios in our feature. So each scenario is essentially like a test, and each scenario has to have a name of some sort or a description. And we have a number of steps. Normally given when then, it doesn't have to be in that order, like it's not strict. You could have a given followed by a when, followed by another given, followed by a then, or something like that. But yeah, obviously, normally that is the natural flow that you want to do things. Something we haven't seen yet is we can have step arguments. So in this case, we're passing in blue and 4 as arguments. So there'll be like a method which is bound to this, and it would have basically parameters in that method which would accept these values. So that's the way that we can, I guess, avoid creating a lot of steps to essentially do the same thing with just using arguments. Background is an optional section that we can add. So background's kind of handy because it lets us add any common preconditions. So if we want to set up all of our scenarios within this feature in a particular way, we can just put it in a background, and that's going to run before every scenario. So in this case, for example, we want to always have a game of set up for 4 players. Data tables are basically like, they act as an argument which can be passed into a step, but it allows us to have a lot more structured data that we want to pass into our test step. That would get very messy if we had to pass all of that as individual arguments, so it's very handy. We can have any number of columns or any number of rows in a data table. We'll see some more examples of that a bit later. So tags is another thing we can add. Just any tag starts with the @ symbol. Tags can be added for a scenario, or they can be added at the feature level. So they're just a way of, I guess, categorizing our tests. Say in XUnit, they end up translating into traits. In MS Test, they translate into test categories. So we can use that for whatever reason you'd normally use that, like maybe you want to control what tests get run in different environments or something like that. And examples, these are really cool. So this allows us to run the same test multiple times with different sets of data. So this is basically the equivalent of a theory attribute in XUnit or a data row in MS Test. So for each one of these rows, it's going to run the test with different arguments for each column. So we can see in this example, on the first run, it's going to pass the red value into color 1. It's going to pass 1 into number 1, blue into color 2. You get the idea. Yeah, these arguments need the angle brackets as well, so that's how we kind of use them as placeholders. Okay, so step arguments. I just wanted to talk a little bit more about this. So we saw before that we can pass arguments into steps, so this is the way we kind of do it in code. We use regex expressions, which allows us to kind of select the criteria, I guess, or the pattern matching for how these arguments get picked up. They have to be surrounded by these round brackets, and then we can have sort of whatever valid regex expression inside of that. So in this case, it's just saying any number of digits, or at least 1 digit or more, and that's going to accept this integer argument. So there are built-in conversions in SpecFlow, so for the basic types like enums, numbers, GUIDs, dates, you don't need to do anything special. As long as the format matches what you would expect, like for integer, obviously, matching just some series of digits, then it will automatically convert it into your argument. But if we want to do something a bit more fancy, we can create our own transformations. So this is an example where we want to transform from a data table. So we saw the data table before where we could provide that in a feature file. And we want to translate that into an enumeration of cards, or like a collection of cards in this case. So how does that work? So what we do is in our feature, we've provided this data table. In our test step, we just have the collection of cards as an input. And so we kind of got the input of the data table and the output of the collection of cards. So automatically that transformation is going to know what to do. And that just saves us having to do all this extra work every time. So that's a pretty handy feature. It's also worth noting that when we create these transformations, we need to add this attribute step argument transformation for that to work. Now by the way, there's more stuff you can learn about SpecFlow if you go online and read up. I'm kind of just going through the basics, just so we can start looking at the API stuff as well. So sharing data. So we saw before, I had an example where I wanted to share like a game instance, and I wanted to share that with some other steps, and I just used the private field. So that's kind of fine if you got everything in a single class, but often you have your steps kind of spread around different classes, so that's not always going to work that well. So we have some other ways we can easily share data between our test steps. The first way is we can just basically inject a model or any class really. So all we do is we create the class that contains whatever we want, and then we just inject it through the constructor into our test class, and it automatically, SpecFlow knows what to do with that. It knows to just create an instance. You don't have to like set up some dependency injection or anything. And that means if we inject it the first time, it's going to create it, and then if another step injects that, then it will just use the existing instance. So I guess you could say it's scoped to the scenario if you think of it in dependency injection terms. Yes, in this example, we can just use that model after being injected. And the other way we can do that is there are two special classes that you can inject. There's a scenario context and a feature context. So we can just inject the scenario context straight into our test class, and there's methods on that, so we can set data and we can also get data. So that's obviously scope for the scenario. The feature context is pretty much the same, except it's scope for the feature. So normally the scenario context is what you want to use, because normally your test data is just related to that scenario, but for whatever reason, if you want to share data between all of your tests and a feature, then you can use the feature context. And the last sort of concept I wanted to talk about on SpecFlow 101 course is hooks. So hooks are just methods that get called automatically at different points within the test run. So they're kind of really good for creating like common functionality, like you might have some common database setup that you want to do for every test or something like that. So there's different levels you can add hooks for. You can have hooks for the whole test run, and there's always before and after hooks, by the way. So that'll just be like run once for the entire suite of tests that you're doing. You can have feature hooks, so that's going to run obviously before and after a feature. You can have scenario hooks, so that's probably the most common that you might use. So that'll be before and after every scenario. And finally, at the finest grain, you can have step hooks. So every single step, you could have one of those hooks called. Okay, so that's kind of wraps up, I guess, the summary of SpecFlow. So just to summarize some of the things we talked about, what are the different elements of a feature file. So we talked about the scenarios and how each scenario can have one or more steps, how we've got that optional background for any common preconditions, how we can have examples where we run a test multiple times with different sets of data, and also how we can apply tags, which we can use for filtering our tests or categorizing our tests. We talked about how we bind steps. We talked about how we just pass in simple arguments, data table arguments if we want to have sort of a more complex setup. And we also talked about how we can create our own custom transformations. With sharing data, we talked about a couple of common ways we can share data using just injecting any class or any model, and also using a feature or scenario context. And we also talked about hooks, where we have those different levels of hooks that we can get called automatically. Okay, so now I'm going to talk about what we specifically did at HAMBS and how we kind of customized the framework so that we could use it for API testing. So I'm just going to talk about some of the goals that we had that led us, I guess, to come to the solution that we did. So obviously we wanted to be able to call API endpoints in our test scenarios, and we wanted to check the responses to make sure we got the response that we expected. We also wanted to set up any database preconditions so that we could, a lot of our tests obviously call the database, so we needed to set up certain database scenarios to test a lot of our things. And we wanted to check the database state after an API call to make sure that if we're adding a record, for example, that record really got added. We ideally wanted to use a language familiar to most of the developers, which in our case is .NET. And we also had a goal, although we didn't initially know how we would achieve this. We wanted to be able to enable developers and testers to create tests. So we wanted something that I guess was powerful, and quite flexible, that developers could kind of get in and do what they want, but we also wanted something that testers could still contribute to those tests and wouldn't be, I guess, blocked by the barrier of having to, understand .NET. And finally, we wanted to maintain a consistent database state between scenarios. So we didn't want to have one test run, update the database, and another test run and fail because, it wasn't expecting the database to be in that state. So these are some of the solutions that we came up with. So we chose SpecFlow as a testing platform, mainly because, well, it's in .NET, which was the first thing, but also because it seemed to satisfy that requirement of having that high-level language still that testers could use without necessarily needing to do any actual code. We created a bunch of shared test steps so that we could sort of satisfy most of the requirements for API testing. So we created steps so that we could just call the API endpoint, so that we could assert the response status and the content, so that we could create records in a database as part of our database setup, and so that after we've called the API, we can check the database and make sure that it's in the state that we expected. And we also added the concept of variables into SpecFlow, which isn't like a native SpecFlow thing. So the idea is, because we wanted to have testers be able to create tests without coding, we kind of needed a way that they could share data from steps. So we came up with this idea of we can have variables, so you can set a variable in one step and then you can pull that variable out in another step. And it's all sort of visible as part of the actual scenario rather than being hidden in code. And to solve our goal of having a consistent database state, we used hooks so that we could restore from a snapshot before each test, which works well, but it is slow, so there's some drawbacks to that approach as well. Okay, so now I'm going to basically show you what we did in terms of our API testing and run through a few different scenarios so you get an idea. Before I do that, I just wanted to, I guess, just show you an idea of the test project that we've got set up. So I just created a dummy web API project for this. It's extremely simple. I've basically got one table. I've got a customer table, which just has a few columns. It's got a customer ID, which is just an auto incremental ID, and then just a few fields. It's got an email address, which has to be, it's got a constraint that it needs to be unique for each customer. And then I just created a really simple minimal API for basically CRUD operations on a customer. So we can get all of our customers, we can get a specific customer, we can add a new customer, we can update a customer, and finally we can delete a customer. And this is the first time I'd used minimal API, so I kind of thought, that gives me a good opportunity to try it out with this demo. So I'm just going to run that web API project. I think I have to drag it across. So this is the Swagger. I mean, there's not much to see there really. It's just the basic CRUD operations, getting, returns an array of customer objects. I'll pop that down there for now. Okay, so just another couple of things to point out, I guess, before I show you the test. So as part of our framework, so this is our framework here. I've just sort of put it here so I can actually run the tests. But there's a fair bit of stuff going on here. There's a lot of common steps that we use, a lot of setup for how we do variables and things like that. And as part of that, we configure a few, that's the wrong project. We configure a few settings as well. So we've got some custom settings here, so call them rec and roll settings. We've got a DB connection string because we want to do the database setup and assertions. We have to configure what services we could hit. So in this case, we've only got a customer service and this is the base URL, but in a real example, you could have multiple services that you want to test. We configure our paths for any external files that we want to use as part of our tests. So most tests are kind of self-contained, you don't need files, but some of our tests are a bit more complicated. So we want to like run a script, for example, as part of our database setup. So that's just telling it the folders to look for when we're looking for those. And yeah, we just configure our logging. So SpecFlow has some logging built into it, but we had some additional logging. So this is just kind of configuring how verbose and things like that we want our logs to be. All right, so I'm just going to run through a few scenarios now so you can get an idea. Okay, so the first one is we just want to add a new customer. So the first step is when a customer service post API with URL/customers is called with a particular body. So what this is doing is this customer part, that's basically referencing the customer that we set up in our service base URL. So that's automatically going to know what the base URL is to use for that. We know it's a post and it's going to append this customer part onto the end of the base URL. This table of data here, so that's going to get translated into JSON. So basically each field would be like a key in our JSON. This is a pretty simple example, but just so that we could do more, like we could have child objects, and if we did like a dot, and then it would kind of create like a whole child object. And so you can do a bit more with it if you need to. So then we want to assert that the response status code was 200, and we also want to check that the response contains a particular JSON packet, so that's translated into JSON again. And then we're going to check the database and make sure that the customers table has a record with these particular values that we just added. So we can go ahead and run that test. I hope I've set everything up all right. All right, did that run? Okay, yeah. All right, so that was successful. I'm just going to show you some of the logs so you can kind of get an idea of what it's doing behind the scenes. So some of these logs just come out of the box as SpecFlow. So this stuff here where it's telling you what step is running, that's just a SpecFlow thing. So the first thing we're doing is we're sending a request to this post API. So you can see the JSON that gets translated from that data table. So basically we're posting to this URL with this data. We received the OK response and we received this data back. We'll get into the variables in just a second, so don't worry about that too much for now. Then we want to check that the response code is 200, which it was. And finally, we want to, we look at the database and we make sure that there's a particular record. So we can see here, that step basically translates into a query on the database. It adds some filters in, so it's filtering based on whatever column values we gave it. And we got one record back, so that passes that particular test. So you can see, like, I mean, this is a fairly simple example, but it's at a lower level than you might normally see with this kind of given-when-then, but it's also at a level that if you understand the API and the database, you could write a test like this relatively easily and you wouldn't have to touch the code. So I'll run through the second scenario now. So we're trying to add a customer with a duplicate email. So in this case, we expect it to fail. So we're going to set up the database this time. We're going to create a new record for Fred Smith with a particular email address. That's part of our given. And then in our when clause, we're going to call this same API again. This time we're going to try to add Mary May, but she's got the same email address as Fred. So we expect to get a 409 or conflict response, and we expect to get a particular error message from that to say a customer with the same email address already exists. And then finally, just as an extra check, we're going to query the database and make sure that Mary May wasn't actually added. So we can run that one. Yeah, so sort of similar to what we showed before. As part of this database setup, we're inserting into the customers table this time with all of the values. This is showing these are the values that we told it to insert. Again, we'll skip over the variable part just for now. Yeah, we called the API and we got a conflict response back, and we got this error message, which is what we expected to get back. And then finally, we queried the database just to make sure that that Mary May record wasn't created, and we got 0 records back. So that test was all good. All right, now I'm just going to show a couple of examples on how we used variables. So the first example, we're just getting an existing customer. Again, we're just going to set up a sort of customer in our database to start with. And then we're going to call this get API. Now, notice that we've got this syntax here. We've got like a dollar symbol and then the curly braces, then customers.customer ID. So that's basically representing how we are formatting variables. So the dollar symbol and curly braces, and then a variable name is how we refer to an existing variable. So that's just going to be like a placeholder. And you might wonder, like, where does that variable come from? We haven't really set it explicitly. So that's coming from when we insert this initial database record, we have some logic behind the scenes that's automatically outputting all of the columns in that table that it's inserted, and then it will automatically create variables based on those names. So the first part of that will be the table name, and then the second part will be the actual column with the value. So that's how we kind of know that should have a value. And then we're just asserting that the request was successful, and we're checking the response body. And yeah, again, we're using that variable as part of that because we should get the customer ID back. So if we run that one. Alrighty. Yeah, so we can see we've inserted into the customer table, and this time we can look at the variables and see that we've created all of these variables for all of the columns in that record. So we've got one for our new customer ID. You can also see with the, we're also creating variables with this colon and then a number. So that's the index. So in case we wanted to insert multiple records at once, we wouldn't really be able to refer to it with a single name. So we also index everyone. So if we had 5, we'd get like 5 customer IDs with a different index on each one. Yeah, so we called our API. We can see here that the actual URL has just inserted that placeholder where we had the variable. And this is the response that we got back. Yeah, we also set variables based on the response fields that we get back from the JSON as well. And yeah, so that test was successful. And I'll just show you one more example using variables. It's a little bit different this time. So this time we're trying to insert a new customer or add a new customer with a future date of birth. So we expect that to fail because we have a rule to say that date of birth has to be in the past. We're using variables, but this is a bit of a different use case. So these are like variable functions or dynamic variables, depending on what you want to call them. So we've got a number that we've put into our framework. So in this case, we want to get a date of birth that is for tomorrow. So this function will basically get us a date of today in the local time, and then it's just going to add one day. and then we're going to save it to another variable called DOB, or date of birth. Similar for first and surname, so we've got another function called name. So here we're saying give us a random name for a male or a female, and make it a first name and with a maximum 15 characters. Same sort of thing for surname. And then at email, we're just basically concatenating those two, the first and the surname together, and then we're just adding @gmail.com. So, and you can see here in our when step, we can refer to these other variables that we've just created as well. So I'll just run that. Alrighty, so we can see in our log here, we've got a bunch of these variables have been created. So we got the date of birth is created for tomorrow's date. Got a random name, we've got Rudd McKeeruff. We've got the email address of his name and @gmail.com. And we're calling that API with that data from those variables. And yeah, we're expecting to get 400 back, and we're expecting to get this particular error, the date of birth cannot be in the future. So that test passed. And just one more scenario that I wanted to show is where we want to use external files. So this would be, I think most tests are more readable if we don't do this, but on occasion you might have a bit more complicated database setup, for example, so you don't want to try to shove all of that into steps because that could get very messy. So in this case, we are retrieving all customers, and we want to set up the database with a bunch of customers to start with. So we're just going to use this script, populate customers, which we have in our SQL folder. So all that's doing is inserting some customers into our customers table. And then we're just going to call the API, the get API for customers. We're going to make sure that the request was successful, and we're going to check that the response body contains the values from all customers, which is a JSON file. So we can have a look at that. So we basically format this as we expect the JSON to be. It doesn't have to contain every single JSON value, like just basically saying it just the end response should contain these values, but it could have additional stuff as well, and that won't fail the test. So if we run that one, all right. So we got a bit of logging saying we basically executed that populate customer script. It affected 3 rows, which is what we expected. We called this API. We got this response back. We set a lot of variables in that case. Yeah, and essentially the response body contained what was in all customers.json. So cool. So that's basically concludes the demo that I had for today. I just wanted to quickly wrap up by talking about some of the benefits of this approach that we took with API testing, and also some of the trade-offs that we found. Sorry, going backwards. Okay. So, yeah, one of the big benefits, because we had all these common steps that were very kind of tailored for API testing and database setup, so it largely avoided the need for creating lots of specific code for each test. So, I mean, sometimes we had special cases where we still had to customize things, but a lot of cases we can basically just use these existing steps and not have to be coding, which was very nice. So another thing that was quite handy was having steps that would work at the API and the database level. So a lot of testing frameworks I've looked at, they don't seem to handle database stuff all that well. Like, they might be good for calling APIs, but then if you want to do anything with the database, you kind of just have to run a script or something. So I kind of liked that we could integrate both of those quite nicely in our test steps. Also, the variables that we introduced made it fairly easy for sharing data between steps without having to touch the code. And I think the biggest benefit was just that the tests are relatively quick to write. So because we've got all these steps, we can kind of bang them out and not have to touch the code, which is, yeah, really good. So trade-offs, yeah, because often with the given-when-then type syntax, we talk about the benefits of BDD testing and being able to translate directly from acceptance criteria. We sort of mentioned it at the start, having that common language between the BAs and the developers and the testers. We do kind of break that a bit with this level of testing because, you know, BAs generally won't want to write tests at the level of actually, you know, inserting data into the database and all of those specifics. So you kind of lose some of that mapping, which is definitely one of the trade-offs. The test scenarios, it kind of leads into that. The test scenarios are harder to read for non-technical people because they're involving some technical details about what the database looks like and exactly what the APIs look like. And yeah, some of the tests do get a bit complicated, particularly if you've got lots of related records. You often, well, not often, but sometimes you need to use external files, and that kind of breaks down the readability of those tests a bit if you have to like look at some other file to kind of understand what's going on. Yeah, that's definitely one of the trade-offs. But overall, I would say the approach I'm pretty happy with. I think it works pretty well. It's very tailored for API testing. Like you couldn't obviously use that and do UI testing or something else. You'd have to come up with a whole bunch of new steps. But I think it worked pretty well, and I think the trade-offs are kind of worth it. And that's pretty much all I had. Yeah, does anyone have any questions or comments?
You just made a comment that sometimes the acceptance criteria that business analysts give you don't map directly into sort of SpecFlow type tests. I found that with a little bit of practice, you can write the language of the SpecFlow test in a way that business analysts can understand. And I kind of adopted the opposite approach where I said, look, if we come up with these SpecFlow tests and we write it in language that you can understand, would you be happy to incorporate these tests into your acceptance criteria?
Yeah.
And I found once we had done that, then if there were minor changes to business rules or logic, and we needed to come up with more SpecFlow tests, then the business analysts were very happy and could understand and relate the change in the business rule. So I kind of found that there was a little bit of, we were using their acceptance criteria initially, but then they were using our SpecFlow tests, which actually became acceptance criteria. And I found there was a lot of benefit in that approach.
Yeah. Yeah, I don't know if that approach, I think that approach will work fine, and I think there's a lot of benefit there. I'm not sure the level that we did it, having like, you know, setting up the database, calling the API with the JSON and that sort of thing. Would you think that would be a bit too low level to achieve that?
Very low level. I found that there was some quite good report generators that actually take the results from the acceptance test and will generate HTML, and I could actually point the business analysts to the HTML test results, and that gave them a little bit more, a higher level of confidence that the tests were being performed and passed.
Yeah, there is
very good tools available that.
Yeah, we did look at so we looked at some of the SpecFlow reporting tools, and I know there's some integration with Azure so that you can kind of get reports and linking between user stories and acceptance criteria being tested. that is one of the, I guess, well, because we're using rec and roll now because of the added support that we're getting with the latest .NET framework, they don't have that aspect of it. They might have it later, hopefully, because that was always a paid aspect, yeah, that wasn't an open source aspect, probably not paid, but I think that part of it with all the reporting was never open source in SpecFlow. So unfortunately, we don't have that with rec and roll at this point, although I guess, you know, you could still do normal kind of reports that you just get from running tests. But yeah, no, I know what you're saying, and I think that was one of the trade-offs that we acknowledged, was that we were writing the tests in a level that wasn't as nice for putting directly into a user story. Like, we could have written it at a higher level, which I think would have been a bit more BA friendly as well, but it also would have involved more code to kind of more custom steps, because it's hard to, you know, it's hard to create enough steps to satisfy so many conditions.
A mindset in how you word the tests,
Yeah.
to make them relatable to the business.
Yeah. Sure.
Have you seen much of a positive impact using SpecFlow to your pace of delivery compared to, say, manual testing?
Well, we have we have a separate test department, and they use some of these tests sometimes, but they kind of also have their own framework. So it's ended up being mainly a developer tool, and we always wanted it to be something that developers would contribute to anyway. Like, we kind of wanted it so that developers could create an API, and then we could create our own, not just unit tests, but our own kind of integration tests, and then we'd be able to immediately verify that our API was, you know, more like a sanity check, I suppose, and do a few happy paths, So I would say it hasn't been fully integrated enough with the whole business in terms of testing. Haven't completely embraced it, and the test manager sort of, you know, has another tool that I guess was selected. So in that way, we might not see the full benefits across the business. But I think we've got a lot of, even just within the development group, we've got quite a lot of benefit of just, you know, like sometimes you can write the unit tests and you can think, oh, that's all good, but then you actually run it and, you know, it falls down. So it's good running at something against the real database and real API. So, yeah.
Have you found that you can replace your end unit tests with SpecFlow tests, or is your intention to run both and keep developing using both?
So we're still running both in the sense that we're still creating unit tests where it's appropriate, like at a more isolated level. Is that what you mean, or?
Yeah, I was involved sort of setting up a similar project as a prototype and a proof of concept, and I was having trouble selling it to the developers.
Yeah.
And the developers were more familiar with NUnit, and they kind of had that mindset.
Yeah.
And this was something new.
Yeah.
And there was quite a different way of looking at how you were structuring the tests.
Yeah.
And I found there was a bit of a learning curve and a little bit of reluctance from developers to move from NUnit to SpecFlow.
Yeah, I guess we haven't attempted to kind of use this to replace our normal unit tests. So we've specifically used it for API testing, and we still have, we use MS test actually, but so we still have separate MS tests which are at the unit level, and they're kind of just standard, not using the given-when-then format. Certainly something we could have done, and I imagine we probably would have got some resistance if we tried to put it across all of our test suite. But
I found a couple of developers really embraced it, really got the hang of it, and enjoyed it.
yeah,
And we had some other developers that were struggling
yeah,
with the new sort of concepts, new construct.
yeah. Can understand. All right, anyone else?
Question is a common BDD related question.
Yeah.
So when we have a BDD framework, how do we recognize whether this particular step is already implemented? Because it's just a sentence like English related sentence in the Gherkin level, and how do we know that we do have this step already linked into a step definition file or not?
Yeah, so mainly the IntelliSense helps quite a lot. So once you build your project, it finds all of those steps that are available, and then when you start typing like given, it will automatically start showing you.
Have to do some prompts instead. Is there an easier tip to find it?
It's a good question. I mean, I guess it's really just up to either IntelliSense or how you structure where you put stuff. So having a logical structure of, like we do have custom, even though we've got this framework of common steps, sometimes we still need custom steps. So we put those alongside the features that are using them. And also well, I didn't explain it before, I didn't go into that, but you can scope your tests to a particular feature if you want. So when you bind it, there's like a special attribute for scoping it. So that does help you so that, because you don't normally want, if it's something very specific, you don't want that to show up in the IntelliSense for all of your other tests. So I guess just having, a consistent structure. So you have your common tests in one place, maybe you categorize them by whatever you want, feature or whatever, and then having specific tests where they belong makes it a bit easier to find stuff.
One of the trade-offs you mentioned, the scenario files are hard to read for non-technical stakeholders. Is that a summary based on the feedback from analysts in your organization? Because I written they're easy to read. At least they can read something written from developer to validate if you are on the same page.
So you're asking if we got feedback on whether the level of the tests was. I think it was really probably based on we wanted testers to be involved in writing them. It's not that we thought testers wouldn't be able to write good tests or understand the database or the APIs well. It was more if it was into the .NET code, that a lot of the testers wouldn't at least have experience with that. So we wanted to at least avoid the necessity of having to write code if you're not a developer, because we thought that might be a bit of a barrier. Not so much still having a level of detail where you'd have to understand the database fairly well to set preconditions up, for example. I think that's totally fine. We assumed that wouldn't really be a big problem. It was more just the actual coding. I mean, like some testing frameworks obviously use scripting, but it's probably not common to use .NET if you're scripting tests, if you've got a testing background. So we just thought we would lower that barrier as much as we could. Does that answer your question or not really?
Yeah.
Okay.
A bit of cover there. During that workshop that we did, and we came out with just looking at problems, bug reports. So over in the business as usual space, where the existing code base, the devs and the testers are actually working together to write those feature files. So it's not just the devs on their own at that point. The BAs did find it a bit hard because we had to set up the database very specifically. So that was really the killer. As Stephen's already pointed out, that was one of the trade-offs that was deliberately made, and it means we've got less boilerplate code lying around in the framework, but there's a bit more effort, a bit more internal knowledge required to be able to set up a test.
Yeah, I agree with that. But at least I think after dev and test
In an ideal world, yes. So it never quite works that way. Yes, sometimes that works. Other times it's just that there's just all that setup and stuff that gets in the way of being able to have a really clear picture of what's being tested, unless you are, at that dev level of having the internal knowledge of the workings.
So in your team, it's still like within the development team.
Very much so. Yeah.
Got it.
Cool. Any more questions? Or?
We've got some
Online as well.
chat as well.
Okay.
If there's no other one.
We got.
So we've got Tarifo said, could you also show the test file to see how the customer API from config was bound to it in an indicated scenario?
Sure. So I think this is referring to how this part gets bound here with the customer.
Could be, I'm not sure when the comment was posted.
Okay, I think actually maybe just drilling into the actual step. So in this example, when step, for calling an API, we have a few regular expressions. So this is just a constant for a regular expression, this thing. Sorry. I think I just pressed the wrong button. All right, let me go back to that again. Yeah, so these are just constants, but they're simple regular expressions as well. So those are the arguments. So we have a few conversions, like we're converting to this HTTP method. The service name's nothing special, but when we call our service API, we have some logic that basically looks up that value from the configuration. So that configuration where we're configuring our service space URL, so it has to match. So we are going to get an error if we provide a value that's not valid. Unfortunately, some of that stuff, we really can't get a build time error for that because SpecFlow doesn't really know anything about that configuration. It just knows about arguments, so we kind of just get a runtime error. But yeah, a lot of it's just custom code, like we have using the normal kind of way that we bind steps in SpecFlow, but then we have quite a lot of, I guess, translation of that. Even like, for example, the URL, we'll run that through something which will check all of our variables and it will substitute any variables that it finds with the real values, and hopefully that answers the question.
And then what's the recommended way to organise a test for a feature? Is it to create a separate test file for each scenario, or put all the scenarios of a given feature in one test file?
Well, I mean, I guess it's probably an opinion thing. We tend to, for our APIs, we tend to break it up based on the actual API. So if it's like a get customer API, then we'll just have all of our get customer scenarios within that single feature. I know it's pretty common to do it based on the user story, so you could have a feature per user story. Yeah, I think there's no rules on it really. It's really just up to the company and what they want to do as a standard. So.
And finally, so the readable feature file is to double check and validate the user story, like providing a bridge for the QA or BA to understand and verify the development work?
It certainly can be used in that way, so that, yeah, you could have the acceptance criteria which directly translates into one of our SpecFlow scenarios, and then you tests based on that, or maybe you've already got some steps that you can use. And you can get some reporting tools that will help kind of link that. So there's even in SpecFlow, there's a reporting tool where it can find all of your, I think it's built into Azure, an integration point in Azure, so you can basically map your user stories into your SpecFlow features, and then you get a nice little report to say, hey, you had all these acceptance criteria, and 3 of them have passed, and 1 of them hasn't been written, and 1 of them failed. And so you can do all that. We're not, at least in what I've been working with, we're not really doing it at that level, and that is partly because of we've chosen to go with this sort of lower level of test where the mapping isn't quite as one-to-one. So. Cool.
Yeah, I have a question about reuse. So
yep.
I think you mentioned that you found you were getting a higher level of reuse of the steps. Do you have some commentary on where specifically you found more reuse? I guess, for instance, is it in the given steps, the when steps, or the then steps, or any example?
I think probably all 3. And most of the reuse comes from the fact that we've done it at a lower level. So, for example, calling an API is generally pretty standard in terms of you don't need a lot of custom. Once you've built in the steps to add the body or specify the URL, specify if it's a get or post or whatever, you don't really need to repeat that. So you can just keep using that step again. So most of our steps would be, most of our scenarios will be reusing most of their steps because they're written in that way that they maximize reuse. So when you're checking the response status as 200, that's just a common step with an argument. You don't have to write something custom for that. So I think that just that lower level kind of really leverages the reuse to the maximum potential. Whereas if we went a higher level and said, when we call the get customer API with a valid customer, that sort of step would kind of lend itself to having to write more custom code, because then you say, okay, how do we translate that statement into actual code? Whereas writing at this level is right, the information's all there. So, yeah. Cool. Well, I think that was all. Thanks very much, everyone.
Thanks, Stephen, and thank you, Rich.